Assalamu alaikum. Hello everyone. Welcome to the video. I'm gonna solve some topical questions. Paper 4, topic 3, atoms, molecules, and compounds. This is IGCSE chemistry, so let's begin. The first question, this is May, June 2017. And this question is about subatomic particles. So, letter A, define the terms proton number and then nucleon number. So, what is proton number? So actually proton number, it is the number of protons within the nucleus of an atom. So proton number is the number of protons within the nucleus of an atom. Second point is, what is nucleon number? So actually guys, nucleon number, this one is the sum of proton number, or you can say protons number, and neutrons number inside the nucleus of an atom. Okay, so here guys, take care. Here we have 3 marks. So here the first one, you will gain a mark. The first one, when you say it's the number of protons within the nucleus of the atom, and here for the second one is the sum of protons and number of neutrons. So the first part here, this is 1 mark, and the second mark would be to say inside the nucleus of the atom. So here we have the 3 marks for point A. Let's go letter B. So why is the H11 hydrogen atom is the only atom to have an identical proton number and nucleon number? Actually guys, remember here in case of hydrogen, within the nucleus, you know, here we have the number down here, this is proton number. It means we have only 1 proton within the nucleus, and at the top we have only 1. And you know that we said little earlier that the nucleon number is the number of, or the sum of protons and neutrons, and here we have 1 proton. It means we don't have any neutrons in this atom. It means we don't have neutrons, only 1 proton. Okay, so in this case the answer should be so, because it has no neutrons. Okay, no neutrons within the 1,1 hydrogen. So let's go point 3. Letter C, complete the table to show the number of protons, neutrons, and electrons in the atom and ions again. Here guys, I think we have to memorize some rules before solve this question. So let's see. If you know that this is X, this X is a symbol for any element. So the number down here represents proton number, and the number at the top represents nucleon number. And here, if you have any charge, whatever it's positive or negative, it means this is like ion. It's not neutral element. And of course, if we don't have any positive or negative, it means this is neutral element. Okay, and also we should memorize something really important, which is this is nucleon number. We said it's the sum of proton number plus neutrons number. Then we can calculate neutrons number by saying nucleon number minus protons number. This is really important guys to memorize before solving the table. Also we should memorize if we have a negative charge, whatever, it's 1, -2, 3, or whatever. So this negative means we will have number of electrons bigger than number of protons. This negative charge here on the right side at the top of the symbol of any element refers to we have number of electrons more than number of protons. In case of we have a positive charge at the top right, any symbol of any element, it means in this case number of protons is much greater than number of electrons. And finally, if we don't have neither negative or positive, here it means it's a neutral or zero, and in this case it means number of protons equals number of electrons, and the atom is electrically neutral. Okay, so please guys remember all of these rules before going to the table. So let's come back. So here's the first question, guys. This is F fluorine. You have this number at the top. This is actually the nucleon number, which is 19. And then in this question, we need to have a periodic table. Of course, everyone will have a periodic table. So let's continue the number of proton number here down for everyone. So for fluorine, okay, you can check this is fluorine. You can find it in group 7. So this is fluorine. And take care, guys, here in this copy of the periodic table, you will find the proton number at the top, and here this is the atomic weight down, okay, at the bottom. So here, this 9, all the time check the smallest number. Of course, the smallest number will be number of protons, and the bigger one will be, of course, number of protons plus neutrons, but here it's atomic weight, okay? Okay, anyway, so we need to pick this 9 for fluorine, and then write it down here. This is 9. And for magnesium, you will find it's 12. So magnesium in group 2. Here magnesium, you see, this is 12. And then for, this is P phosphorus. For phosphorus, it's going to be 15. So it's in group 5. This is phosphorus. Here, this is 15. P. Okay, 15. And finally, this is strontium. It's going to be 38, group 2 as well. So this is strontium. You will find it's 38. Okay. So by knowing this proton number, now we can complete the table simply. So this is 38. Now let's go for number of protons. You know this 9, it's called proton number. So here number of protons is going to be 9. Okay, so this is 9, and you know, because here we don't have a check, we don't have any charge over here. Here we don't have any charge. It means it's a neutral. It means number of protons equals number of electrons. Okay, here because we don't have any charge, negative or positive. Okay. What about the number of neutrons? Remember the rule, we said number of neutrons equal, yes, nucleon number minus this number, nucleon number, this one, minus proton number. It means 19 minus 9. So 19 minus 9, of course, equals 10. So here it's 10. Okay. I think the first one was easy, so let's go to the second one, which is magnesium. Take care, guys, this magnesium also here we don't have any charge, positive or negative. It means it's neutral as well. So proton number is 12. It means electron number is 12 as well. Okay. What about number of neutrons? The same here. We take nucleon number, which is 26. 26 minus, and this number, which is proton number, 12. So 26 minus 12, so it's going to be 14. So the number of neutrons is going to be 14. Okay. Third one, take care here we have 3 minus. 3 minus, remember the rule, it means that we have number of electrons more than number of protons. Okay. So what is number of protons? Proton number is down here, it's 15. Okay. And electron number should be more than number of protons by this 3. So it means 15 plus 3, this 3 extra electrons, to be 18. So number of electrons is going to be 18. And finally, what about neutrons? The same, we say 31. In this case, we say 31 minus 15, nucleon number minus proton number. So it's going to be 16. The last one, this is strontium. Here we have also a charge. This charge is positive. In case of positive, if you remember, we said here proton number or number of protons will be more than number of electrons. So here, guys, here we have 38. This is 38 protons. Okay, so 38. And then number of electrons should be less than this proton number by 2. Because we said proton number must be more than number of electrons by this 2. So this is 38. It means we say 38 minus 2. So it means it's 36. So here number of electrons is 36. And finally number of neutrons is 1. Should be nucleon number 87. 87 minus 38. So it's going to be 49. Okay, I think it's easy, but please make sure you memorize the rules before starting. Okay, let's go to the next question. This is May June 2018. Fluorodium FL atomic number 114 was first made in research laboratories in 1998. Letter A, fluorodium was made by bombarding atoms of plutonium Pu atomic number 94. So this is Pu, and its atomic number down here 94. Okay, and this is fluorodium Fl, and its atomic number down here is 114. Okay, and now with atoms, element Z. The nucleus of one atom of plutonium combined with the nucleus of one atom of element Z. This formed the nucleus of one atom of fluorine. The first question is, suggest the identify of element Z. Actually, guys, we need to continue this one before solving, because we should know that this fluorodium is produced because of bombarding of the plutonium Pu-94. It means if we have Pu-94, it's bombarded by an element Z, we don't know it right now, to produce fluorodium Fl. This is 114. Okay, you know, guys, here this is 94, and of course this element Z, we don't know what about its atomic number over here or proton number, but finally you should remember here that the sum of proton number of plutonium plus proton number of Z should equals 114. Okay, so it means the proton number for Z should be 114 minus 94. Okay, because the sum of them will produce 114. Okay, so 114 minus 94 equals 20. So the atomic number here is going to be 20. So we discovered after calculation that this element Z, its atomic number, or we say proton number, is 20. So let's check in the periodic table what is 20. Of course, it's calcium. See, this is calcium, 20. So what is the element now? So the element is going to be calcium. Okay. Next one, letter B. In which period of the periodic table is fluorodium? Let's check in the periodic table. Where is fluorodium actually? So this is Fl. See, guys, this is Fl, fluorodium 114. So let's count the number of the period. We start by helium. This is period 1, and then period 2, 3, 4, 5, 6, and then finally this is period 7. So here is this is fluorodium in period 7. Okay, so this is period 7. Okay, so letter C, predict the number of outer shell electrons in an atom of fluorine. Now we should predict the number of outer shell electrons. We need to know the number of electrons in the outer shell. You know, guys, we can predict according to the group number. Here, this is group number. Okay, so this is here group 14, but simply we can count from group 1. This is group 1, and then group 2, and then we can go to group 3, and then this is group 4. Okay, so group 4 means we have 4 electrons in the outermost shell. Here, take care, guys. The block in the middle, which is a transition meter, actually we don't count it because it's not, they don't form representative elements. We count only group 1, 2. Here we can cancel this block in the center or in the middle, and then continue here group 3, group 4. Okay, so here we have 4 electrons. Number of electrons is going to be 4. Letter D, 2 isotopes of fluoridium are Fl286 and Fl289. The nuclei of both of these isotopes are unstable and emit energy when they split up. First one, I state the term used to describe isotopes with unstable nuclei. Actually, guys, the word unstable nuclei, and here it said emit, yes, emit energy. So emit energy and unstable nuclei, it means it's radioactive. So radioactive plus isotope, so it produces radio, something called radioisotope. Okay, it's called radioisotope. Okay. Next one, double I, complete the table to show the number of protons, neutrons, and electrons in the atoms of the isotope shell. Okay, here the same rules, guys, we can use. So remember, just for fluoridium, the proton number, it's 114, both 114. You know, proton number, take care, this is like, all the time I said, this is like fingerprint. Proton number is fixed number. It's like fingerprint for humans. So here 114, this is 114, the same. Only the difference in the nucleon number due to the difference in the number of neutrons. Okay? So number of protons here is going to be 114. The same here for the second one, 114. Proton number is fixed number of protons. Okay, what about number of electrons? Let's check please here. We don't have any charge. We don't have any charge. Okay, so it means same number of electrons because this is neutral atom. So 114, and here is the same 114. Okay, what about number of neutrons? Okay, here number of neutrons means nucleon number, this one, minus proton number. So it means 286 minus 114. Okay, so it's going to be 172. So it's going to be 172. For the second one, we can do the same, but in this case, we will take this number, which is 289. This is the number, minus 114. So it's going to be 175. You can copy it here, 175. Okay, guys, clear? So next one, here point E. Only a relatively small number of atoms of fluoridium have been made in the laboratory, and the properties of fluoridium have not yet been investigated. It has been suggested that fluoridium is a typical metal. Here the question I suggest 2 physical properties of fluoridium. Here it said that fluoridium is a typical metal. And here we need 2 physical properties of fluoridium. Actually, the question asks about 2 physical properties of typical metals. So you have a lot of properties, you can choose any 2. For example, you can say it's for fluoridium, it's, you can say shiny, You can say ductile. Okay, any property. Second one, you can say it has high melting point. So actually, guys, it's up to you. You can choose any two physical properties of typical metals to write them down here. Okay. Here, the last question, double I suggest one chemical property of fluorodium oxide. Okay. Fluorodium oxide, actually, fluorodium is a metal, typical metal. So fluorodium oxide refers to a concept called the metal oxide, right? So it's metal oxide. So what is the property we can suggest for any metal oxide? Actually, guys, so it's called the basic oxide. Okay, so fluorodium oxide is going to be a basic oxide. What does it mean, basic oxide? Basic oxide, this is not only for fluorodium oxide, this is for all metal oxides. Metal oxides, they form basic oxide. Basic oxide means they can dissolve in water to produce alkaline solution. Okay? Hope you find this helpful. Thank you so much, guys. See you inshallah next time. Bye.